What if the universe still resonated with the echoes of its birth? This audiobook invites you to discover an invisible yet real phenomenon, primordial gravitational waves. They are believed to have emerged in the very first moment of the Big Bang, when space itself stretched faster than light, and although billions of years have passed, those waves could still be traveling through the cosmos, waiting to be detected. A journey through the oldest traces of the universe, where understanding the origin can change everything. At the heart of this story are the waves of the Big Bang, an echo of the moment when everything began. Imagine the universe as a vast ocean. The waves of the Big Bang are the ripples on the surface of the water, a whisper of what happened in that primordial instant. These waves offer us a way to listen to the past, to capture fragments of information about how everything around us was formed. The importance of studying the Big Bang lies in its ability to help us understand not only how the universe was created, but also how it has evolved. From the formation of the first particles to the creation of galaxies, each stage is a step on the ladder that leads us to comprehend our existence. Why is it essential to know this? Because it connects us to the cosmos in a profound way, revealing that we are part of something much larger than ourselves. The Big Bang is not just a theory, it is a window into the past. This idea has evolved from the first sparks of curiosity in the scientific community to become a robust framework that explains the history of the universe. By exploring its origin, we find answers to questions that have intrigued humanity for centuries. How did everything begin? Why is the universe expanding? What lies beyond what we can see? As we delve into this narrative, it is crucial to understand how the expansion of the universe has shaped what we see today. Imagine a balloon being inflated. As it expands, the marks on its surface move away from each other. In the same way, galaxies are constantly separating, and this expansion is proof that the universe is not a static place but a dynamic environment in constant change. Cosmic inflation, an intriguing concept in this context, tells us that in the early moments after the Big Bang, the universe experienced exponential growth. Have you ever wondered how something so immense can grow so quickly? This phase of rapid expansion is key to understanding the uniformity of the cosmos we see today. Without it, the universe would be a much more chaotic place. Gravitational waves, on the other hand, are like the ripples created when a stone falls into a pond. These waves allow us to explore cosmic events, such as the merging of black holes, and are intimately linked to the history of the Big Bang. Capturing these waves is like trying to hear a whisper in the midst of a storm. It is a challenge, but each detection brings us closer to understanding the mysteries of the universe. We cannot talk about the cosmos without mentioning dark matter and dark energy, two components that make up most of the universe. Although we cannot see them directly, their influence is palpable. Dark matter acts as an invisible scaffold that holds galaxies together, while dark energy is the mysterious force that accelerates the expansion of the universe. Together, these elements are part of the great puzzle that scientists are trying to solve. Cosmic background radiation is another fundamental piece of this story. It is a faint glow that fills the universe, an echo of the first moments after the Big Bang. By studying this radiation, scientists can look back in time and gain insight into what the universe was like when it was just moments old. It is like looking through a window that allows us to see the past in its purest form. Meanwhile, nuclear synthesis, the process that gave rise to the first elements, is the next chapter in this story. In those chaotic moments of the early universe, protons and neutrons combined to form the first atoms of hydrogen and helium. This act of creation is the foundation of everything that exists, from stars to planets, including our Earth. Now, as we look towards galaxies, we discover that their formation is related to small irregularities in the distribution of matter. These imperfections, which initially seemed insignificant, were the seeds that gave rise to the large structures we see today. Thus, the universe became a place full of life and diversity, where each galaxy tells its own story. Antimatter, although it seems like a concept taken from science fiction, also has its place in this narrative. It is like a mirror of matter, and its existence raises fascinating questions about balance in the universe. Why is there more matter than antimatter? This is one of the many questions scientists strive to answer. Finally, black holes, those mysterious and powerful objects of the cosmos, are related to the story of the Big Bang. Their formation is a reminder that even in the death of stars, there is a cycle of creation and destruction that continues. Gravity plays a central role here, shaping the universe and creating a fabric that connects everything, from planets to galaxies. As we progress on this journey through the universe, we encounter theories like string theory, which seeks to unify the fundamental forces. Thus, modern cosmology becomes an effort to understand not only the origin but also the ultimate fate of the universe. Technology and research have opened new doors, allowing us to observe beyond what our eyes can see. The search for life on other planets intertwines with these explorations, suggesting that the expansion of the universe may be key to understanding whether we are alone in the cosmos. The possibility of finding life beyond our planet leads us to reflect on our own existence and our place in this vast universe. As we delve into these paradoxes and mysteries, it is important to remember that each answer leads us to new questions. The expansion of the universe is not only a physical phenomenon, it also has profound philosophical implications for humanity. It invites us to reflect on our place in the cosmos and what it means to be part of a constantly changing universe. In summary, by studying the Big Bang and its waves, we find ourselves on a journey that transcends time and space, revealing the history of our universe and challenging our understanding of existence itself. Human curiosity drives us to continue exploring, seeking answers, and perhaps finding a deeper meaning in our connection to the cosmos. The Big Bang, a term that evokes both wonder and curiosity, is the most accepted theory about the origin of the universe. But what does it really mean? Imagine a moment when time and space did not exist as we know them. Everything we now consider the cosmos was concentrated in an infinitely small and dense point. What happened next? From that instant, everything began to expand rapidly. This is how the history of the universe takes its first great step. To understand the Big Bang, it is essential to go back in time. In the 1920s, an astronomer named Edwin Hubble made a surprising discovery. He observed that galaxies were moving away from each other, suggesting that the universe is not static but is in constant expansion. This revolutionary idea was the spark that ignited the Big Bang theory. But why is it so important? Because it offers us a glimpse into how everything began, a look at the history of our existence. As we explore the Big Bang, we find a moment of transformation. In that first instant, the fundamental forces of the universe, such as gravity and electromagnetism, were united as one force. Over time, as the universe expanded and cooled, these forces separated, giving rise to the interactions we know today. But what does this mean for us? It means that every star, every planet, and of course ourselves, are the result of that incredible cosmic explosion. The Big Bang theory is not only based on observations, but also on a series of evidence. One of the most fascinating is cosmic background radiation. This phenomenon is like an echo of the Big Bang, a kind of background noise that fills the universe. It is considered one of the pillars of modern cosmology and offers us clues about the conditions of the universe in its early moments. Can you imagine being able to hear what happened billions of years ago? Well, that is the essence of this radiation. However, the Big Bang is not just an event, it is the beginning of a journey that leads us to understand how the first particles, atoms, and eventually the elements that make up everything we see today were formed. Nucleosynthesis, a process that occurred in the first minutes after the Big Bang, created the lightest elements such as hydrogen and helium. This creation of matter is crucial because without it, we would have no stars, no planets, and no life itself. How amazing is it to think that our bodies are made of atoms that formed in those initial moments? As the universe continued to expand, small irregularities in the distribution of matter began to play a fundamental role. Imagine a blank canvas where spots of different sizes are drawn. Over time, some of these spots become galaxies, while others collapse into stars. Thus, matter clusters and shapes the cosmic structures we observe today. It's like a cosmic dance that has been ongoing for billions of years in this vast universe. Antimatter also plays an intriguing role. Although we do not see it in abundance in our everyday environment, it is believed to have been created in similar amounts to matter during the Big Bang. So why are we surrounded by matter and not antimatter? This question has puzzled scientists for decades. Each answer brings us a little closer to understanding the nature of the cosmos. The connection between the Big Bang and black holes is another fascinating part of this story. As the universe expanded and cooled, stars formed, and eventually some of them collapsed into black holes. These mysterious objects are the result of the death of massive stars and have a significant influence on the structure of the universe. What secrets do they hold? What happens inside them? The search for answers remains a challenge for astronomers. As all these processes occurred, gravity acted as a fundamental force shaping the universe. Imagine gravity as a giant magnet that attracts everything around it. Without it, galaxies would not have the shape or structure we observe today. Gravity not only attracts, but also plays a crucial role in the expansion of the universe. As the universe expands, gravity acts to keep galaxies and their components together. In this vast story, primordial matter is the foundation of everything we know. But what was it exactly? In the first moments after the Big Bang, the universe was composed of a hot soup of particles. As it cooled, these particles combined to form the first atomic nuclei. This process was essential for the birth of matter as we know it. Modern cosmology has advanced remarkably thanks to technology and research. With more powerful telescopes and sophisticated tools, we have learned a great deal about the Big Bang and its legacy. The observation of gravitational waves, for example, has opened a new window to investigate the most energetic events in the universe. Who knows what other discoveries await us in the future? Finally, the impact of the Big Bang is not limited to science. It leads us to reflect on our place in the universe. What does it mean for us to be part of this cosmic story? As we explore the philosophical implications of the expansion of the universe, we are confronted with profound questions about existence and the meaning of life. The quest for answers to these questions can be as fascinating as the universe itself. Thus, the Big Bang remains a mysterious threshold through which we explore our past, present, and future. From its initial explosion to the complexity of the structures we see today, every element of this story invites us to keep investigating, to keep questioning, and to keep marveling at the immensity of the cosmos. The expansion of the universe is a fascinating concept that may seem challenging, but in reality, it is more accessible than it appears. To better understand it, let's think about a balloon. Imagine you have a deflated balloon in your hands. As you start to inflate it, every part of the surface of the balloon moves away from the others. This is exactly what is happening to the universe. Since the moment of the Big Bang, our universe has been expanding, and it continues to do so at an astonishing rate. So what does it really mean that the universe is expanding? When we talk about expansion, we are not referring to galaxies moving through space like cars on a road. Instead, it is the very space between the galaxies that is stretching. Imagine that each galaxy is a point on the surface of a balloon. As the balloon inflates, those points move farther apart. This is how the universe works. Space itself is expanding. An intriguing question is, why is the universe expanding? The answer has to do with the energy left over from the Big Bang. Right after that initial explosion, the universe was extremely hot and dense. Over time, as it expanded, it cooled down and allowed matter to begin to form, but that primordial energy is still present, driving the expansion of the universe. It's as if once you ignited a rocket, the initial energy kept pushing it forward. But how do we know that the universe is really expanding? This is one of the most exciting questions in cosmology. In 1920, astronomer Edwin Hubble made an astonishing discovery. He observed that galaxies that are farther away from us are moving away faster. This phenomenon, known as Hubble's law, suggests that the farther away a galaxy is, the faster it is receding. It's like being on a high-speed train and seeing that the trees that are farther away pass by more quickly than those that are close. Through the observation of galaxies, scientists have been able to measure the rate of expansion of the universe, which also leads us to a fascinating question: how fast is it expanding? This rate, known as the Hubble constant, has been a topic of debate for decades, and different measurement methods have yielded slightly different results. Some scientists have suggested that there might be dark energy behind this acceleration, a mystery we are still trying to solve. An intriguing idea about the expansion of the universe is that it is not constant. From certain observations, astronomers have discovered that the expansion has accelerated over the last billions of years. This means that in the future, the galaxies we see now could move away from us at a speed that would make them invisible. Imagine trying to see a friend driving away in a car at high speed. Eventually, they will disappear from view. This is the future that could await some of the galaxies we know today. The expansion of the universe raises another fascinating question. How does this affect our own place in the cosmos? As the universe expands, our own galaxy, the Milky Way, is also moving. In fact, our galaxy is not alone, as it is part of a group of galaxies known as the local group. However, even among neighboring galaxies, the expansion of the universe remains a factor. Although nearby galaxies may be gravitationally bound, the more distant ones continue to recede. It is important to note that this expansion is not felt in our daily lives. On Earth, gravity keeps our planet, our homes, and even our solar system together. The gravitational force is so powerful on small scales that it counteracts the expansion of the universe in our immediate surroundings. So, while the universe expands, we continue to live our daily lives without feeling this movement. What about the shape of the universe? Is it flat, closed, or open? These questions are fundamental to understanding how the universe will behave in the future. Observations have indicated that the universe is flat in terms of geometry, which means that on very large scales the rules of Euclidean geometry apply. This has profound implications for the ultimate fate of the universe. If it is flat, that could mean it will continue to expand forever, although at an ever slower rate. Now let's reflect on the impact of the expansion of the universe on our understanding of time. As the universe expands, our perception of time also changes. The light from distant galaxies that we see in the night sky is a glimpse into the past, as the light takes billions of years to reach us. As the universe expands, the galaxies we observe are witnesses to a time that no longer exists. This connection between time and the expansion of the universe is a reminder that our place in the cosmos is dynamic and ever-changing. In the end, the expansion of the universe is not just a physical phenomenon, it is a concept that challenges our understanding of reality. It invites us to think about the vastness of the cosmos and how each of us is a tiny part of something much larger. Each discovery about the expansion brings us a little closer to unraveling the mysteries of the universe and our place within it. The search for answers continues, and each question opens the door to new wonders and discoveries. Thus, as we reflect on the expansion of the universe, let us remember that each day is an opportunity to explore, learn, and marvel at what surrounds us. Cosmic inflation is one of those fascinating ideas that challenge our understanding of the universe. But what exactly is cosmic inflation? To understand it, we must travel back to the most primordial moments of the universe, to a time when everything we know was a small, hot, and dense ball of energy. In an instant, everything changed. But why and how did this happen? The theory of inflation holds that in a fraction of a second, barely a whisper in the vastness of time, the universe experienced exponential expansion. Imagine you have a balloon and you inflate it quickly. In the blink of an eye, that balloon goes from being a small dot to filling an entire room. Similarly, the universe expanded incredibly fast. But what triggered this explosion of growth? One of the keys to understanding cosmic inflation is energy. At that primordial moment, there was a form of energy known as the inflationary field. This field acted like a kind of engine that drove the expansion. But what role does this field play in the history of the universe? The answer lies in how it shaped the structure of the cosmos as we know it today. This growth not only increased the size of the universe, but also sowed the seeds of the galaxies, stars, and planets that would later emerge. Another intriguing question is, why don't we feel this inflation in our daily lives? The reason is that inflation occurred on a scale so ridiculously small that we have no way of experiencing it at a human level. While we live in a universe that is constantly expanding, inflation was a fleeting and almost magical event that took place at the dawn of time. When considering cosmic inflation, questions about the uniformity of the universe also arise. Why is it so homogeneous on a large scale? Inflation could be the answer. By expanding so much, the small irregularities in the density of matter were distributed evenly, creating the mosaic we see today, where galaxies are spread more or less uniformly in space. But inflation not only explains the uniformity of the universe, it also makes it more intriguing. Imagine a universe that had not gone through this rapid expansion. We could have ended up with a cosmos filled with irregularities, where galaxies formed in a chaotic and disorderly manner. However, thanks to inflation, we have an ordered universe where the largest structures have formed over time. One of the most fascinating questions is, what about the areas of the universe that lie beyond what we can observe? Inflation suggests that there may be regions of the cosmos that we will never see as they are expanding faster than light. Imagine a world where there are parts of the universe that are completely out of our reach, filled with mysteries and perhaps even life. As we explore more about cosmic inflation, we also encounter quantum physics, that strange and wonderful part of science that seems to defy common sense. During inflation, quantum fluctuations may have been amplified, leading to the density variations that resulted in the formation of galaxies. So, in a sense, quantum chaos played a crucial role in the order of the universe. This raises another question. What does this mean for our understanding of reality? If quantum fluctuations can affect the very fabric of the cosmos, what other things might be interconnected in ways we do not yet understand? The universe seems to be a place where the small and the large are intertwined in surprising ways. As scientists attempt to unravel the secrets of inflation, they use tools like telescopes and satellites that observe the cosmic microwave background. These instruments allow astronomers to capture the echoes of inflation and better understand how the universe formed. But what other mysteries will these observations reveal in the future? Cosmic inflation is not just a theory, it is an open door to deeper questions about time, space, and the universe itself. It invites us to consider that what we see is only a fraction of what truly exists. Therefore, when reflecting on cosmic inflation, we find ourselves at the crossroads of science and philosophy, where each answer generates new questions. As scientists continue to investigate, the mystery of cosmic inflation reminds us that there is still much to discover. What other truths about our universe lie hidden in the corners of the cosmos? As we continue to explore, each new finding brings us a little closer to unraveling the secrets that surround us. Cosmic inflation, in its essence, is a reminder that the universe is a dynamic and ever-changing place. It invites us to maintain curiosity and an open mind because at the end of the day, every discovery about the cosmos is also a discovery about ourselves. Did you know that the universe is not only expanding but is also filled with waves that tell us stories about its origins? These waves, known as gravitational waves, are products of extremely powerful cosmic events and have a direct relationship with the Big Bang. But what exactly are they, and why are they so important to us? Gravitational waves are disturbances in the fabric of space-time, somewhat like the ripples that form on the surface of water when you throw a stone. Imagine that space-time is a large, calm lake. When a massive object, like a black hole or an exploding star, moves, it generates waves that travel throughout the universe. These waves can be detected by very sensitive instruments here on Earth, providing us with valuable information about events that occurred billions of years ago. The discovery of gravitational waves is relatively recent but has revolutionized our understanding of the cosmos. In 2015, scientists from the LIGO experiment announced that they had detected these waves for the first time, as if they had opened a new window to the universe. The detection of these waves not only validates Einstein's theories about gravity, but also allows us to observe the universe in a way that was previously unimaginable. Now, how are these waves related to the Big Bang? Think of the Big Bang as the initial moment of the universe, an explosive event that produced an immense amount of energy and matter during that instant. Space itself began to expand, creating waves that propagated through everything we know. These waves are considered echoes of that first explosion, allowing us to hear what happened in those primordial moments. Gravitational waves not only offer us a connection to the past, but are also linked to other phenomena in the universe. For example, when two black holes collide, they generate powerful gravitational waves that can traverse the universe, telling us about the merger of these massive bodies. It's as if the universe is sending messages through a radio signal system, and we, with our technology, are beginning to tune into those frequencies. Imagine being able to hear the music of the universe. Each collision, each supernova explosion produces a unique melody in the form of gravitational waves. By studying these waves, scientists can hear what is happening in the cosmos, sometimes even before the light reaches us. This opens a new field of study in astronomy, where the investigation of gravitational waves becomes a fundamental part of understanding the mysteries of the universe. But it's not all straightforward. Detecting these waves is a real challenge. It requires incredibly advanced technology and extreme precision, as the disturbances they generate are minuscule. For example, when detecting gravitational waves, instruments must be able to measure changes in distance of less than a millimeter over a distance of 4 kilometers. It's like trying to measure the thickness of a hair from several blocks away. Moreover, gravitational waves can provide us with clues about the nature of some of the most mysterious components of the universe, such as dark matter and dark energy. As we advance in the detection and study of these waves, we may begin to unravel some of the deepest secrets of the cosmos, from the formation of galaxies to the ultimate fate of the universe. One of the intriguing questions that arise about gravitational waves is whether they could help us better understand the expansion of the universe. The answer is yes. By analyzing how these waves behave in different parts of the cosmos, scientists can gain insights into how gravity influences expansion and how structures form and evolve over time. As we continue to explore, we must also consider the philosophical impact of these discoveries. Gravitational waves not only provide us with scientific data, but also make us reflect on our place in the universe. Every time we hear a new wave, we are reminded of how small we are compared to the vastness of the cosmos. So the next time you think about the Big Bang, remember that it was not just an explosion of matter and energy, but also generated waves that still traverse the universe. These waves are the thread connecting the past and the present, and every time we detect them, we are one step closer to understanding the mysteries that surround us and our place in the vast fabric of the cosmos. Gravitational waves are, in essence, the echo of the universe, a reminder that there is always something more to discover. As we continue to explore and learn, these waves will keep guiding us in our quest for answers, opening the door to a future full of possibilities and astonishing discoveries. Have you ever wondered what dark matter and dark energy really are? Although we cannot see them, they are two of the most enigmatic and fundamental components of the universe. Together, they make up about 95% of all the matter and energy that exist. Yet their nature remains a mystery. Imagine the universe as a large cake, and what we can see, like stars, planets, and galaxies, is just the small layer of frosting on top. Most of the cake, the actual content, is hidden, and we do not fully understand it. Dark matter, on one hand, is like a shadow surrounding galaxies. Although it does not reflect light and we cannot directly detect it, its presence is felt in the way galaxies rotate. Why do galaxies spin in a way that does not seem to match the amount of visible matter within them? The answer lies in dark matter. Scientists have deduced its existence from how galaxies move and cluster into groups. Without dark matter, our galaxies would not have enough gravity to hold themselves together. It's as if they are keeping a secret that we have yet to decipher. On the other hand, dark energy is even more intriguing. While dark matter acts like cosmic glue, dark energy seems to be pushing the universe toward expansion. Imagine you are inflating a balloon. At first, the air is distributed evenly, but as you keep inflating it, the balloon expands faster and faster. Dark energy is the force behind that acceleration. What drives this dark energy? That is the question scientists are still trying to answer. Now, to complicate things further, it should be mentioned that dark energy is not just an abstract concept. It represents about 75% of the universe, and its effect has been felt since the discovery that the universe is expanding. How did scientists know the universe was expanding? It all began with the work of astronomer Edwin Hubble in the 1920s, who observed that galaxies were moving away from each other. This discovery led to the conclusion that the universe was not only expanding, but doing so at an accelerated rate. The question now is, what does this mean for us? If dark energy continues to accelerate the expansion of the universe, what will happen in the future? Will galaxies continue to drift apart until they are so distant that we can no longer see them? This scenario, known as the Great Tear, raises a series of questions about the fate of the universe. The idea that the universe could keep expanding forever suggests a future where stars extinguish and galaxies slowly recede into darkness. And here is where dark matter and dark energy intersect. Without dark matter, the structures we see in the universe, like galaxies, would not exist. However, dark energy seems to counteract that structure, pushing toward a future where everything is moving away. This creates a delicate balance that scientists do not yet fully understand. Can you imagine if we could find a way to directly measure dark energy? Imagine the possibilities. We could better understand how the universe works and perhaps even discover how to manipulate those forces. However, for now, we can only observe its effects and speculate about its nature. At the heart of all this complexity, there is an intrinsic beauty in how dark matter and dark energy interact. They are like two dancers in a cosmic choreography, moving in perfect sync as they create the stage of the universe. Although we cannot see them, their influence is undeniable and fundamental to our understanding of the cosmos. In summary, dark matter and dark energy are two of the greatest enigmas of the universe. Although we cannot see or touch them, their existence is crucial for the functioning of the cosmos. Without them, our universe would be a very different place, and continuing to investigate and seek answers is essential to unraveling the mysteries that still await discovery. It is a reminder that although we have made progress in our understanding of the universe, there is still much to learn. The quest for answers about dark matter and dark energy leads us to reflect on our own existence and the place we occupy in this vast and incredible cosmos. What else does the future hold in our exploration of the universe? Only time will tell. Cosmic background radiation is one of the oldest echoes we can hear from the universe, a melody that began to play when the cosmos was just a few 100,000 years old. But what exactly is this radiation, and why is it so crucial for understanding our existence? In simple terms, cosmic background radiation is a kind of thermal noise that fills all of space, a remnant of the moment when the universe cooled enough for atoms to form and light could travel freely. This phenomenon can be imagined as the heat that remains after a great fire. When the fire goes out, the heat doesn't disappear immediately. It lingers in the air, enveloping everything around it. Thus, cosmic background radiation is the remnant of the great fire of the Big Bang, the light that has been trapped in the fabric of the universe since its earliest moments. But how do we detect it? In 1965, two scientists, Arno Penzias and Robert Wilson, encountered a mysterious buzzing in their radios. After many experiments and ruling out possible sources, they realized they were listening to this cosmic background radiation. Their discovery was a monumental moment, confirming that the universe not only began with a bang but still retains the echo of that event. Can you imagine the excitement of realizing they were hearing the voice of the young universe? The temperature of this radiation is approximately 2.7 degrees above absolute zero, a temperature that turns out to be quite cold. However, it is important to remember that in the context of the cosmos, this temperature is still remarkably hot. Cosmic background radiation not only tells us about the state of the universe in its infancy, but also provides clues about its evolution. How do we know this? By studying the distribution of this radiation, cosmologists can infer how structures in the universe have formed and grouped together. For example, small variations in the temperature of cosmic background radiation indicate the presence of matter densities that led to galaxies and clusters of galaxies. It's as if we have a map of the universe in its early days, where each small change in temperature tells us a story about the matter and energy that existed at that time. Some may wonder what this tells us about how the universe is structured today. The answer is fascinating. The small fluctuations we observe in cosmic background radiation are the foundations of what would later become the grand cosmic structures we see today: galaxies, clusters, and filaments of matter stretching across the cosmos. It's like a canvas on which galaxies have been painted, each stroke and shadow speaking of a story of growth and expansion. But why is cosmic background radiation so important in the quest for answers about our universe? Because it acts as a silent and ancient witness, a snapshot of a time when everything was much simpler and more homogeneous. It allows scientists to test theories about the formation of the universe and its physical laws. Without it, many of our assumptions about how everything began would be in the dark. Cosmic background radiation also raises intriguing questions. What if this radiation holds more surprises beneath the surface? Some scientists are investigating the possibility that there are hidden patterns or anomalies that could offer clues about phenomena not yet understood, such as dark matter or dark energy. It's fascinating to think that when we observe cosmic background radiation, we are actually looking back in time to the moment when the universe was just beginning to form its essence. Each photon that reaches our detectors is a time traveler, crossing billions of years to tell us about the past. However, cosmic background radiation is not just a remnant of the past, it also has implications for the future. As the universe continues to expand, the temperature of this radiation will keep decreasing. This leads us to wonder, what will happen to this light in the distant future? Will it continue to witness the evolution of the universe, or will it fade into silence? In this context, cosmic background radiation also invites us to reflect on our own existence. What does this echo of the Big Bang mean for us as a species? It reminds us that we are part of a much larger story, a narrative that has been woven over billions of years. The quest to understand cosmic background radiation is also a quest for identity. It connects us with the universe, reminding us that, although we are small in the vastness of the cosmos, we are made of the same stars that shone in the past. Therefore, as we look up at the sky and contemplate the stars, we can imagine that we are listening to the ancient melody of cosmic background radiation, a song that resonates through time and space, telling us about our origin and the destiny that still awaits discovery. In every flash of light, in every temperature fluctuation, there is a tale waiting to be told, a reminder that the universe remains a fascinating and complex enigma, full of mysteries yet to be unveiled. Nuclear synthesis is one of the most fascinating processes that occurred in the early moments of the universe. But what does this term really mean? In simple terms, it refers to the creation of the first chemical elements in the universe. Just after the Big Bang, that's right, in that primordial explosion, not only was dark matter and energy generated, but also the fundamental building blocks of life, atoms. Imagine for a moment a huge furnace where conditions are extreme, with temperatures exceeding millions of degrees. In that environment, protons and neutrons, which are the basic pieces of atoms, come together to form nuclei of helium, hydrogen, and other light elements. This happened in the first 3 minutes after the Big Bang, a period that scientists have called the era of nucleosynthesis. But why is this process so important? The answer is simple. The elements formed at that moment are the same ones that make up everything we see around us. From the air we breathe to the stars in the sky. Without nucleosynthesis, there would be no atoms, and without atoms, there would be no molecules and no life. So who are the main characters in this story? Mainly hydrogen and helium. About 75% of the universe is composed of hydrogen, while helium makes up around 25%. Now let's talk about an intriguing aspect. Did you know that heavier elements, like carbon and oxygen, were not formed in that first stage? In reality, these elements were generated later inside stars. So, in a way, we are children of the stars. But returning to nucleosynthesis, it is amazing to think that in those early moments, the foundations of everything we know were laid. But how do we know this really happened? Through observation, scientists have detected the proportion of these elements in the universe. For example, using telescopes and advanced techniques, they have been able to measure the amount of helium and other light elements in the oldest stars. These observations match the predictions made about nucleosynthesis, strengthening our understanding of how the universe originated. Imagine that every time we look at the sky, we are contemplating not just a vast space, but an open book that narrates the story of our existence. Each star shines with the echo of that ancient cosmic furnace that forged the first elements. It is a reminder that we are all connected in some way to those epic moments in the history of the universe. One of the most fascinating aspects of nucleosynthesis is how it relates to the Big Bang theory. This theory suggests that everything that exists began in an extremely hot and dense state. As the universe expanded, it cooled, allowing protons and neutrons to come together to form atomic nuclei. But what about electrons? These particles, which orbit around the nuclei, joined them later, when the universe became cool enough to allow their formation. Nucleosynthesis not only explains how elements were formed, but also raises intriguing questions about the fate of the universe. If everything began with the Big Bang and nucleosynthesis, where are we headed? Will the universe continue to expand indefinitely, or will there come a time when everything collapses? These are questions that scientists continue to explore. Now let's take a look at the relationship between nucleosynthesis and life itself. All the elements that make up our bodies, such as carbon, oxygen, and nitrogen, were created in the hearts of stars that lived and died before our solar system existed. This leads us to a profound reflection. We are the result of a cosmic process that began billions of years ago. The matter that composes us has traveled through time and space, connecting our existence with the universe. Nucleosynthesis also invites us to consider the role of physics in the creation of the universe. The fundamental forces of nature, such as gravity and the nuclear force, played a crucial role in the formation of elements. Without these forces, nuclei would not have been able to come together, and the universe would be a very different place. This reminds us that the laws of physics are part of the cosmic story. As we reflect on these topics, it is important to remember that nucleosynthesis is not just a phenomenon of the past. It also has implications for the future. The way elements are distributed in the universe affects the evolution of galaxies and ultimately the possibility of life on other planets. What does this mean for the search for extraterrestrial life? The answer is intertwined in the history of nucleosynthesis and the formation of the universe. Every discovery in this field brings us one step closer to understanding our place in the cosmos. Science continues to advance, and each new finding provides us with a greater understanding of how elements formed and how they influence the structure of the universe. Nucleosynthesis is just one piece of the puzzle, but it is a fundamental piece that allows us to connect the history of the universe with our own existence. Finally, it is amazing to think that through science we can glimpse the events that shaped our universe. Nucleosynthesis is a testament to the power of human curiosity and our desire to understand the unknown. By exploring this process, we not only learn about the origin of elements, but also connect with our own history and the history of the universe. So the next time you look at the stars, remember that you are also part of that cosmic story. In the vast stage of the universe, galaxies are the great actresses of the cosmic play. Have you ever wondered how these enormous structures form and evolve from the initial moments of the universe? The answer to that question takes us on a fascinating journey through time and space, where small irregularities in the distribution of matter played a crucial role. When the universe began, it was a dense and hot soup of subatomic particles. However, as it expanded and cooled, these particles began to clump together. Imagine you are at a party where everyone is very close together. As the music plays and the party progresses, some people start to group together, forming small clusters. This is how it began to happen in the universe. Small fluctuations in the density of matter, like bubbles in a soda, began to attract more matter towards them, forming the first groups of matter. The small irregularities in the distribution of matter were like the seeds of a cosmic garden. Some of these seeds, upon receiving enough matter, grew and became galaxies, while others faded into the vastness of space. But what made these seeds thrive while others did not? The answer lies in gravity, a force that acts like a magnet, attracting matter towards itself. The denser a region was, the stronger its gravity, allowing it to attract more and more matter. Galaxies do not arise from nothing. They are the result of a continuous process of growth and merging. Imagine you have a snowball at the top of a mountain. As it rolls down, it picks up more and more snow along the way, becoming larger and larger. In this way, the initial galaxies merged with each other, forming even larger structures. This merging process has also been key in the evolution of the universe, creating a cosmic landscape full of diversity. As galaxies formed, matter was not distributed evenly. Some areas became very dense, while others remained empty. This translates into a universe full of wonders, where we find galaxies at different stages of development. Some are young, filled with bright and new stars, while others are old and dying, with stars that have already exhausted their fuel. As we look up at the sky and see these galaxies, we are not just observing distant objects, we are looking back in time. The light they emit has traveled millions, even billions of years to reach us. Each galaxy we see is like an open book that tells the story of its own formation and evolution. Isn't it amazing to think that each point of light in the sky is, in itself, a world of history? But what about the galaxies we see today? How are they connected to the universe of the past? Astronomical observations have allowed scientists to determine that galaxies are in constant motion, moving away from each other as the universe expands. This expansion is not just a recent phenomenon, it has been occurring since the Big Bang. Each galaxy is part of a dynamic process where the interaction between them can lead to the creation of new structures. Galaxies also have a life of their own. Like living beings, they are born, grow, and eventually die. Some may become supermassive black holes at their centers, a fate that seems common for many galaxies. This black hole is not just an end, but a new beginning, as it influences the evolution of the galaxy itself, affecting the formation of new stars and planetary systems. Understanding galaxy formation also leads us to reflect on dark matter. This mysterious substance does not emit light and therefore cannot be observed directly. However, we know it is there, as its gravity influences the movement of galaxies. Dark matter is said to be like the skeleton of the universe, providing the necessary structure for galaxies to stay together. Furthermore, the study of galaxy formation also gives us clues about the evolution of life in the universe. As galaxies form and evolve, they create heavy elements in their cores, which are then released into space when they die. These elements are the same ones that form planets and eventually life itself. From a cosmic perspective, every star in the sky has the potential to be a home for life. But not everything is a fairy tale. Interactions between galaxies can be violent, like collisions that trigger the formation of new stars, but can also lead to the destruction of others. These events are part of the life cycle of galaxies, and while they can be chaotic, they are also necessary for the evolution of the universe. The formation of galaxies is a reminder that the universe is a constantly changing place, where structures emerge and evolve over billions of years. Each galaxy is a story in itself, a saga of birth, growth, and sometimes destruction. and while there is still much to learn about this process, what we have already discovered gives us a fascinating insight into our place in the cosmos. In the end, galaxy formation is not just a matter of physics and gravity, it is a cosmic dance that connects us all. Each of us, every atom of our being, was forged in the heart of a star in a galaxy that may no longer exist. So the next time you look at the starry sky, remember that every star you see is part of a much larger story. A story of creation and connection in the vast universe. Antimatter is one of the most fascinating and enigmatic concepts in the universe, a true puzzle that sparks the curiosity of scientists and enthusiasts alike. But what exactly is antimatter, and why is it so important for our understanding of the cosmos? To grasp this, we must first imagine that every particle of matter has its counterpart of antimatter. Think of an electron, which is a particle that is part of the atoms that make up everything we know. Its opposite, the antiparticle, is a positron. Instead of having a negative charge like the electron, the positron has a positive charge. This relationship between matter and antimatter is like a cosmic dance, where each step has a pair that complements it. The universe as we know it seems to be filled with matter, but curiously, antimatter is extremely scarce. Why did this happen? In the first moments after the Big Bang, it is believed that equal amounts of matter and antimatter were generated. However, something mysterious occurred that led to the predominance of matter. Imagine a huge jar filled with marbles of different colors. If you open the jar and let them fall, you expect most of them to stay on the ground. But what if somehow one of the marbles slipped away and disappeared? That is what is believed to have happened with antimatter in the primordial universe. The disappearance of antimatter has led many to wonder, what would happen if we encountered it? The answer is quite surprising. When a particle of matter meets its counterpart of antimatter, an instantaneous annihilation occurs, releasing a tremendous amount of energy. This is comparable to the explosion of a small nuclear bomb. Imagine you have a balloon filled with air and suddenly you poke it. The air rushes out quickly and the balloon disintegrates. That's how intense the reaction between matter and antimatter is. This property has led scientists to explore the possibility of using antimatter as an energy source, but of course this is just an idea on the horizon filled with challenges. What about its role in cosmology? Antimatter could be the key to solving some of the greatest mysteries of the universe. Some theories suggest that if there were enough antimatter, it could influence the expansion of the universe. But how could this be possible? Imagine the universe as a large spider web. Matter and antimatter would be like two types of threads that intertwine. If one of these threads breaks or fades away, the web as a whole could be affected in ways we do not yet fully understand. One of the most intriguing questions about antimatter is whether life based on it could exist. Can you imagine a completely different form of life made of antimatter? Although this idea sounds like science fiction, scientists are taking it seriously. There could be distant worlds where antimatter is not as scarce as in our own universe. However, the difficulty of creating and storing antimatter here on Earth makes it a monumental challenge. In some experiments, small amounts of antimatter have been produced, but maintaining it is a challenge. Since it must be stored under very specific conditions, antimatter is extremely difficult to handle. In this sense, scientists are like magicians trying to keep a dragon at bay that wants to escape. What if we managed to create an efficient method for storing antimatter? The possibilities would be almost infinite. Currently, particle accelerators such as the Large Hadron Collider are essential tools for studying antimatter. These giants of science allow researchers to create conditions similar to those of the primordial universe, where antimatter and matter could have formed in equal amounts. By understanding how antimatter behaves in these environments, scientists hope to gain insights into its scarcity and its role in the universe. Antimatter also has fascinating implications in theoretical physics. Some physicists suggest that it could play a role in gravity and the behavior of space-time. Imagine that antimatter has the ability to curve space in a way we have not yet discovered. This could open new avenues for understanding phenomena such as the accelerated expansion of the universe, or even help in the search for a unified theory that explains all fundamental forces. The question of why the universe is mostly made of matter and not antimatter remains one of the great mysteries of cosmology. There are theories suggesting that the laws of physics may have favored matter at the moment of the Big Bang. But to understand this, we need to delve into the behavior of subatomic particles and how they interact. Each advance in this field brings us one step closer to solving the enigma of antimatter. The search for antimatter has also led to the creation of innovative technologies. For example, positrons are used in positron emission tomography, a medical imaging technique that helps detect diseases like cancer. Thus, without realizing it, antimatter is present in our lives in ways we never would have imagined. Antimatter is not only a fascinating topic at a scientific level, but it also raises profound philosophical questions. The existence of a reality where antimatter is common leads us to reflect on the nature of our own universe. Are we alone in a cosmos filled with matter? Or are there other worlds where antimatter reigns? These questions invite us to explore beyond the known, towards a future where antimatter could be an integral part of our understanding of the universe. As we continue to investigate and unravel the secrets of antimatter, we cannot help but wonder, what other mysteries does the universe hold for us? Antimatter is just the tip of the iceberg, a reminder that there is still much to discover. Ultimately, the adventure of understanding antimatter is a journey into the depths of the cosmos, a journey that is just beginning. What happens when matter is compressed so much that not even light can escape? This is the question that leads us to the fascinating world of black holes, those mysterious cosmic objects that seem to challenge the rules of physics as we know them. In the vast universe, black holes are like cosmic vacuum cleaners devouring everything around them, and their existence is closely tied to the Big Bang. But how do they form, and what role do they play in the fate of the universe? To understand the formation of a black hole, it is essential to know the life of a star. Imagine a massive star, a large sphere of burning gas that shines brightly. For most of its life, this star is in equilibrium, with the pressure of the hot gas inside pushing outward and gravity trying to crush it inward. However, when a star exhausts its nuclear fuel, that delicate balance is broken. Gravity wins and the star collapses in on itself. This collapse is the climax in the life of a star, an explosive event that can lead to a supernova, a brilliant burst that can outshine an entire galaxy. But what happens after this explosion? If the star was massive enough, it can leave behind a remnant so dense that its gravity becomes uncontrollable. This is how a black hole forms, a region of space where gravity is so intense that nothing, not even light, can escape its pull. But what does this mean for the universe as a whole? Black holes are not just solitary devourers. They play a crucial role in the evolution of galaxies. As supermassive black holes found at the centers of many galaxies accumulate matter and energy, they can influence the formation of new stars and the dynamics of galaxies as a whole. It has been proposed that the activity of these black holes may regulate the growth of galaxies, like a conductor ensuring that each instrument plays in harmony. And here arises an intriguing question. Are black holes really the end of everything, or could they be gateways to other universes? Some theories suggest that they could act as wormholes, connecting different points in space-time. Although this idea sounds like science fiction, the physics behind it leads us to explore even stranger and more fascinating concepts. The relationship between black holes and the Big Bang also raises profound questions. It is thought that black holes may be the result of the collapse of extreme densities of matter, something that also occurred in the earliest moments of the universe. This leads us to wonder, could there be black holes that formed shortly after the Big Bang? Some scientists believe so, and that these holes could contain information about the universe's earliest moments. Another intriguing aspect is the information paradox. When something falls into a black hole, it seems that information about that object is lost forever. However, physicists have debated for decades whether this information is truly lost or if somehow it can be recovered. This question not only challenges our understanding of gravity and quantum mechanics, but also makes us reflect on the nature of reality itself. As we explore black holes, we find that they are not all the same. There are different types: stellar black holes, which form from the collapse of massive stars, supermassive black holes, which reside at the heart of galaxies, and intermediate black holes, about which we still know very little. Each of them has unique characteristics and plays a distinct role in the architecture of the cosmos. The exploration of black holes is not just a theoretical exercise. Thanks to advances in technology, we have been able to observe phenomena related to them. The first image of a black hole, released in 2019, was a monumental milestone in astronomy. Capturing the shadow of a black hole not only confirmed the existence of these cosmic mysteries, but also opened the door to many questions about how they interact with their environment. On the other hand, the life of a black hole is not eternal. Over time, through a process known as Hawking radiation, black holes are believed to evaporate. This idea challenges the notion that they are indestructible entities and raises the question of what happens to the matter and energy they possess. Do they dissipate into space, or do they transform into something new? As science advances, so does our understanding of black holes and their relationship with the universe. The latest theories on quantum gravity are taking us to new frontiers, where the concepts of space and time could be radically different from what we know. Are we on the verge of discovering a new way to understand reality? The exploration of black holes also has profound philosophical implications. It pushes us to question our place in the cosmos and what it means to be human in such a vast and mysterious universe. In this sense, black holes are more than just astronomical objects. They are a mirror reflecting our own questions about existence and destiny. In conclusion, black holes are one of the most fascinating and enigmatic aspects of the universe. From their formation from the collapse of stars to their influence on galaxies, their study helps us unravel the secrets of creation and the structure of the cosmos. Each discovery we make brings us one step closer to understanding the vast and mysterious universe we inhabit. What other secrets do black holes hold? Only time and future research will reveal them. String theory is like a vast ocean of possibilities that seeks to explain the complexity of the universe. Imagine that each of those waves represents a fundamental force of nature. The strings, which are the essence of this theory, are like tiny vibrating threads that shape everything that exists. But what exactly are these strings, and how can they be the key to understanding the universe? To begin, visualize music. Every note we hear comes from strings vibrating in an instrument. The tighter the string, the higher the note. In string theory, the universe would be composed of tiny strings vibrating at different frequencies. These vibrations determine the properties of particles, such as mass and charge. Thus, instead of thinking of individual particles, we can imagine them as different manifestations of these vibrating strings. But why do we need a theory like this? Often in physics, we try to bridge two worlds, that of quantum mechanics, which describes the very small, and that of general relativity, which describes the very large. String theory presents itself as a bridge between these two realms, offering a way to integrate all the forces of nature into a single coherent structure. Isn't it fascinating to think that everything in the universe could be interconnected through these strings? The idea that everything is linked through strings also leads us to reflect on the very nature of space and time. In string theory, space is not just an empty stage where events occur. Imagine that space is like a spider web where the strings intertwine and create a framework that holds all of reality. This concept challenges us to reconsider our notions about existence itself. As we delve into this world of strings, an intriguing question arises. What about dimensions? In our everyday experience, we perceive 3 spatial dimensions and 1 of time. However, string theory suggests that there could be additional dimensions hidden from our view. Imagine a world unfolding beyond what we can see, where those strings vibrate in dimensions we have never experienced. This is not only exciting but also opens the door to new possibilities about what the universe could be like. In the quest for a unified theory, scientists have faced many challenges. The mathematics involved in string theory is extremely complex. Some would say it is like a three-dimensional puzzle where each piece must fit perfectly to reveal the complete picture of the universe. But what if the answers are not in the mathematics, but in intuition? Could we come to understand the universe on a deeper level if we stepped away from numbers and immersed ourselves in the beauty of ideas? String theory also has fascinating implications for our understanding of gravity. Did you know that one of the aspirations of this theory is to explain how gravity works at the quantum level in our everyday world? Gravity is the force that keeps us grounded, but at the subatomic level it behaves surprisingly. String theory suggests that gravity could be the result of strings moving in additional dimensions, which could change our perception of this fundamental force. A captivating aspect of string theory is how it relates to matter particles. Instead of being independent entities, particles are seen as different manifestations of those vibrating strings. This idea invites us to rethink our understanding of the material world. What if the essence of matter is nothing more than the vibration of strings in a vast cosmic stage? However, despite its elegance, string theory still faces criticism and doubts. Some scientists question whether it can truly be confirmed through experiments. The lack of direct evidence has led many to consider the theory a beautiful idea, but perhaps too abstract. This raises the question, can a theory be valid even if it cannot be conclusively tested? The answer to this question remains a topic of debate in the scientific community. As we reflect on string theory, it is essential to consider its impact beyond physics. Imagine how this idea could influence our philosophy and our understanding of humanity in the universe. If everything is interconnected through strings, what does this mean for our perception of life, death, and purpose? Science and philosophy can intertwine in a dialogue that pushes us to explore the great questions of existence. String theory has also inspired many artists and writers. The idea of a vibrant and connected universe has found its way into literature and the arts, creating a rich tapestry of narratives that explore the nature of reality. Could it be that our stories, like the strings, are connected in a vast web of shared experiences? Ultimately, string theory is a reminder of how little we know about the universe and how vast the questions that remain to be answered are. Each discovery in this field leads us to new inquiries and explorations. Are we truly ready to comprehend the immensity of what lies beyond our perception? The strings could be just the beginning of an endless journey toward knowledge. So, as we continue to explore the nature of the universe, let us remember that each theory, each idea is a thread in the great fabric of existence, and in that weave, each of us has a place vibrating in harmony with the cosmos, in search of answers that bring us closer to understanding the mystery of our own reality. Gravity is one of those forces that seem simple but are actually incredibly complex and fascinating. What if I told you that this force, which keeps us glued to the ground and determines how planets move, also plays a fundamental role in the expansion of the universe? Gravity, far from being just a physical concept, is the thread that weaves the history of the cosmos from the Big Bang to the present. To understand how gravity influences the expansion of the universe, we must first consider how it works. Imagine that gravity is like a huge invisible net that traps everything around it. The more massive an object is, the stronger its attraction. Thus, planets, stars, and galaxies are affected by this force that, although we cannot see, has an immense impact on the structure of the universe. When the universe began to expand after the Big Bang, gravity played a crucial role in the history of this expansion. In its early moments, the universe was filled with energy and very hot. As it cooled, particles began to form and eventually atoms. But what happened to all those particles? Gravity began to do its work, attracting matter and forming the first structures of the cosmos. The expansion of the universe is not a uniform phenomenon. Some regions expand faster than others. Why does this happen? The answer lies in the distribution of matter and energy in the cosmos. Areas with a higher concentration of matter attract more material through gravity, which can even cause the expansion to slow down in certain zones. In contrast, in areas with less matter, the expansion may be faster. Thus, gravity acts as a regulator in this cosmic dance. As galaxies formed, gravity also began to influence their behavior. Two galaxies approaching each other may end up merging, creating a larger galaxy. This process is a clear example of how gravity not only affects expansion but also shapes the very structure of the universe. It's as if gravity were a sculptor transforming matter into increasingly complex forms and structures. But what about the expansion itself? Many wonder if this expansion will continue indefinitely, or if at some point gravity could reverse this process. At its core, there is a struggle between the expansive force of the universe and gravitational attraction. This tension is crucial for understanding the future of the cosmos. Some theories suggest that if gravity manages to overcome expansion, we could experience a big crunch in which the universe contracts into a tiny point. However, recent observations have revealed a surprising aspect. It seems that the expansion of the universe is accelerating. How is it possible that gravity is not stopping this expansion? The answer may lie in the mysterious dark matter and dark energy, components that we do not fully understand and that seem to dominate the dynamics of the universe. Gravity by itself cannot explain this phenomenon, leading us to explore new frontiers in cosmology. Scientists are working hard to unravel these mysteries. Imagine astronomers as cosmic detectives, searching for clues in the sky that help them understand how gravity and expansion interact. Each observed galaxy, each analyzed supernova provides crucial data that feeds our theories about the universe. Gravity also plays a role in the formation of black holes, those mysterious objects that seem to defy the laws of physics. When a massive star exhausts its fuel, its own gravity can cause it to collapse in on itself, creating a black hole. These black holes are not only fascinating for what they are, but also for their influence on the surrounding space. They act like magnets, attracting matter and in some way contributing to the structure of the universe. In this context, gravity is not just a passive force, it is a main actor in the history of the cosmos. It helps us understand how galaxies cluster, how galaxy clusters form, and how matter is distributed in the universe. Without gravity, the history of the universe would be completely different. The expansion could have led to a chaotic cosmos, without the beautiful structures we can observe today. And so, gravity also invites us to reflect on our place in the universe. We are part of this immense cosmic fabric where every star, every galaxy, every black hole is interconnected. Understanding gravity allows us to appreciate the complexity of the interactions taking place in the cosmos, and at the same time reminds us how small we are compared to the vastness of the universe. In conclusion, gravity is much more than a simple force. It is the element that shapes the universe, balances expansion, and connects us all in this vast sea of stars. As we continue to explore the mysteries of the cosmos, gravity will remain an essential key to unraveling the secrets of our origin and destiny in the universe. What is primordial matter, and how did it form in the early universe? To understand this, we need to go back in time to a moment immediately after the Big Bang, when the universe was an incredibly hot and dense place. At that time, space and time as we know them did not exist. Instead, there was a hot soup of subatomic particles that were in constant motion and collision. But what happened after that initial explosion? Primordial matter refers to the particles that formed in those early moments of the universe. In this extremely energetic environment, particles such as protons and neutrons were created, which are the building blocks of atoms. However, before those atoms could form, these particles were in a chaotic and uncontrolled state. It was only when the universe began to expand and cool that the opportunity arose for these particles to combine and form atomic nuclei. But why is primordial matter so important? Imagine you are building a house. First, you need the materials like bricks and cement before you can raise the walls. Similarly, primordial matter was essential for constructing the universe as we know it today. Without it, there would be no stars, planets, or even us. As the universe cooled, a process called nucleosynthesis occurred, where protons and neutrons joined together to form the first nuclei of hydrogen and helium. This process was fundamental, as these elements would be the basic components for the formation of stars and galaxies. Therefore, primordial matter was not only the first step in the creation of the universe, but it also laid the groundwork for the formation of everything we see today. Imagine the universe as a large garden. At first, there was only soil and nutrients, but as it was watered and cared for, the first plants began to grow. Similarly, primordial matter was the fertile soil that allowed stars and galaxies to bloom. Without those first seeds of matter, the cosmic garden would never have grown. Like everything in nature, primordial matter also has its secrets. There are still unanswered questions about how it behaved in those early moments of the universe. For example, why are there more protons than antiprotons? This difference is crucial, as if there were an equal amount of both, the universe would be a very different place, almost empty, since matter and antimatter would annihilate each other. So how do we know all this? Thanks to observation and research, scientists have been able to study the cosmic microwave background radiation, which is like a photograph of the universe in its infancy. This echo of the Big Bang provides us with clues about the amount of primordial matter that existed. It is like a fingerprint that helps us identify and understand the processes that occurred in those crucial moments. But there is a fascinating paradox related to primordial matter. Although we know it formed in large quantities, a significant portion of the matter in the current universe is unknown to us. Where does dark matter come from? This mysterious component of the universe does not emit light or energy, making it practically invisible and very difficult to study. However, its influence is evident in the way galaxies cluster and move. Primordial matter also leads us to question the conditions necessary for life. Is it possible that in other corners of the universe there are forms of life that developed from different combinations of matter? This opens up a range of intriguing possibilities about the diversity of life in the cosmos. In this sense, primordial matter becomes a bridge to a deeper understanding of our place in the universe. It invites us to reflect on how we are connected to those first particles that gave rise to everything. Every atom in our body, every bright star in the sky, is made of the same matter that formed in that primordial moment. As we continue to explore the universe, primordial matter will remain a fascinating subject of research. Each discovery brings us a little closer to understanding not only how everything began, but also how it has developed over billions of years. The search for answers is far from over. Each new finding in physics, astronomy, and cosmology brings us closer to unraveling the mysteries that still surround us. Primordial matter is just one of many pieces in this cosmic puzzle, but it is undoubtedly one of the most fundamental. So the next time you look at the stars, remember that at their essence lies a legacy of primordial matter, connecting us all in a shared story of creation and discovery. The exploration of the universe is ultimately a journey toward understanding ourselves. In this vast cosmos, each of us is an echo of that primordial moment, a reminder that we are part of something much larger. Modern cosmology is like a grand adventure in the vast ocean of knowledge. As we navigate its waters, we discover amazing tools and technologies that allow us to see beyond what our eyes can capture. But what has led us to this exciting journey? The answer lies in insatiable human curiosity and our need to understand the universe around us. Since the development of the telescope in the 17th century, scientists have been able to observe the sky in ways that were previously unimaginable. This instrument, though simple compared to what we have today, opened a door to a universe filled with stars, planets, and galaxies. However, the telescope is not the only hero in this story. The advent of modern technology has revolutionized our understanding of the cosmos. How? By providing us with more precise and powerful tools. Radio astronomy, for example, has allowed us to listen to the radio waves emitted by celestial bodies. These waves are like the fingerprints of the universe, revealing valuable information about its composition and behavior. Imagine being able to hear what a star is saying through its radiations. This type of technology has enabled us to detect inexplicable phenomena such as gravitational waves that tell us about cataclysmic events in space. Apart from radio astronomy, we have space telescopes that orbit the Earth, like the famous Hubble Space Telescope. This observatory has sent stunning images of distant galaxies to Earth and has contributed to measuring the rate of expansion of the universe. Each image it sends is a fragment of the past, an echo of light that has traveled for billions of years. But what does this mean for modern cosmology? It gives us a window into the past, allowing us to understand what the universe was like when it was just beginning to form. As scientists have gathered data through these tools, they have begun to build a map of the cosmos. But what about the mysteries that still haunt us? We still do not fully understand the nature of dark matter and dark energy, two components that seem to dominate the universe. How is it possible that something we cannot see has so much power over the expansion of the cosmos? These questions are the driving force behind research in cosmology. Computer simulations have also played a crucial role in our understanding of the universe. By creating mathematical models that simulate the evolution of the cosmos, scientists can observe how galaxies form and evolve over time. These simulations are like a cosmic video game, where we can experience different scenarios and see how small changes can have significant repercussions on the structure of the universe. But modern cosmology does not stop there. International collaboration has enabled significant advances in research. Projects like the Laser Interferometer Gravitational Wave Observatory, LIGO, have brought together scientists from different parts of the world in the quest for answers about the most extreme phenomena in the universe. This global cooperation reflects the importance of sharing knowledge and resources in the exploration of the cosmos. And what about artificial intelligence? Machines are beginning to play a fundamental role in astronomy. Through advanced algorithms, scientists can analyze enormous amounts of data in the blink of an eye. This not only speeds up the discovery process, but also allows for the identification of patterns that might otherwise go unnoticed. Are we on the brink of a new era in understanding the universe thanks to technology? Space exploration has also been a fundamental pillar of modern cosmology. Missions to Mars, the Moon, and beyond have expanded our boundaries. Each mission not only seeks answers about our solar system, but also raises questions about the possibility of life on other planets. As we discover new worlds, we wonder, are we alone in the universe? However, despite the advances, cosmology still faces challenges. The search for a unified theory that explains all the fundamental forces of the universe is one of the greatest puzzles. Could string theory provide the answer we have been seeking? The scientific community continues to explore this and other theories in an attempt to unravel the secrets of the cosmos. The future of cosmology is bright and full of possibilities. As we continue to develop new technologies and explore the universe, we will surely encounter more questions than answers. But perhaps that is the essence of science, an endless journey of discovery and wonder. Human curiosity is what drives us to look up at the sky and ask what lies beyond. In summary, modern cosmology has evolved by leaps and bounds thanks to the combination of advanced technology, international collaboration, and unyielding human curiosity. Every discovery we make is another step on the ladder toward a deeper understanding of the universe. And while there is much we still do not know, what is certain is that the journey has only just begun. Astronomical observations have revolutionized our understanding of the universe, but how can we study something so vast and distant? The answer lies in the tools and techniques that astronomers have developed over the years. Each instrument is like a special eye that allows us to see different aspects of the cosmos, from visible light to gravitational waves that tell us about cataclysmic events in the universe. Telescopes are perhaps the most well-known instruments. But not all telescopes are the same. Some are designed to capture visible light, like those we see in the night skies. Others, such as X-ray or infrared telescopes, open new windows to realities that are invisible to the naked eye. Thus, each type of telescope acts as a translator, converting different forms of energy into images and data that we can interpret. Can you imagine being able to see objects millions of light years away? Thanks to these telescopes, that is possible. Radio astronomy is another fascinating facet of observation. Using giant antennas, scientists can listen to the radio waves emitted by cosmic objects. These waves are like whispers from the universe, revealing secrets about the formation of galaxies and the existence of dark matter. Each signal we capture is like a message in a bottle that has traveled through space for eons, waiting to be deciphered. But what about gravitational waves? This phenomenon, predicted by Einstein's theory of relativity, was first detected in 2015. These waves are like ripples in water generated by extreme events such as the merging of black holes. Capturing these waves requires specialized facilities like LIGO and Virgo, which are capable of measuring tiny changes in spacetime. Imagine trying to hear a melody in the middle of a noisy concert. That is what these detectors do. Every time they manage to capture a signal, it is a monumental triumph for science. Satellites also play an essential role in our observations. From space, they can capture data without the interference of the Earth's atmosphere. These observations are vital for studying cosmic microwave background radiation, an echo of the Big Bang that provides clues about the beginning of the universe and its evolution. Every measurement we take from space brings science closer to answering fundamental questions about our existence. Spectrographs are other allies in this quest for knowledge. These instruments split light into its component colors, allowing us to analyze the chemical composition of stars and galaxies. By observing the spectrum of light emitted by a celestial object, we can infer its temperature, speed, and even its distance. It's as if we are reading the biography of a star just through its light. Computer simulations have transformed our ability to understand the universe. By creating models that mimic the behavior of galaxies and dark matter, scientists can test theories and make predictions about what we should observe. These simulations are like experimenting with a virtual laboratory, where variables and conditions of the cosmos can be manipulated without leaving Earth. Another crucial tool is space probes. These explorers travel to the far reaches of the solar system, sending back data and photographs that help us better understand our cosmic neighborhood. From the Voyager probe, which has traveled beyond the planets, to missions to Mars, each mission is a step toward understanding our place in the universe. However, astronomical observation is not limited to advanced technology. International collaboration is fundamental. Astronomers from around the world share data and work together on massive projects such as the Hubble Space Telescope. Science is a team effort, and each discovery is built on the shoulders of giants. Education also plays an essential role in astronomical observation. Through science outreach programs, interest in astronomy is fostered from an early age. Workshops, talks, and hands-on activities allow more people to connect with the cosmos, sparking curiosity and nurturing new generations of scientists. The evolution of observation technologies is intrinsically linked to advances in physics and mathematics. As our theories about the universe become more complex, so do our tools. For example, infrared imaging technology has allowed scientists to see through clouds of gas and dust, revealing forming stars that were previously invisible. Each new advance brings us closer to unraveling the mysteries of the cosmos. As astronomers continue to explore the universe, they also face challenges. Light pollution on Earth affects the quality of observations. However, initiatives to protect the night sky are underway, and innovative solutions are being developed to maintain the integrity of our skies. The fight to preserve darkness is as important as discovery itself. Finally, every observation we make not only provides us with data, but also invites us to reflect on our existence. When we look at the stars, we do not just see distant objects. We see the history of the universe, a tale that spans billions of years. Each discovery is a spark of curiosity that drives us to keep probing, to keep asking. Astronomical observation is In essence, an endless journey where each answer opens the door to new questions and mysteries to solve. In this vast universe, the quest for knowledge never stops. The search for life on other planets has intrigued humanity since time immemorial. Since we first looked up at the starry sky, we have wondered if we are alone in the vast universe. With the expansion of the universe, this question becomes even more fascinating. How does the expansion of the cosmos influence the possibility of other habitable worlds existing? The universe, like an inflating balloon, is constantly expanding. As galaxies move away, so do the opportunities to find new homes in the vast darkness of space. But what does this mean in terms of life? If the universe continues to expand, could there be worlds in distant corners that are forming right now? The answer is a resounding yes. Every day, scientists discover new exoplanets orbiting distant stars, some in zones where conditions might allow for the existence of water, a vital component for life as we know it. This phenomenon of the universe's expansion not only increases the distance between galaxies, but also raises questions about how matter is distributed. As space expands, resources like hydrogen and helium are spread throughout the cosmos. These elements are the building blocks of planets. In distant worlds, they could be forming oceans, mountains, and perhaps even life. But what if the expansion of the universe makes those worlds inaccessible to us? Imagine an endless relay race. As the runners advance, they separate more and more. How do we reach those who are light years away? The answer lies in our technology and our innate curiosity. Telescopes and space probes are our tools for exploring those distant corners. Thanks to them, we have been able to observe planets that lie in the habitable zone, where conditions are ideal for life. What if we find signs of life on one of those planets? Scientists have posed this question and have begun to seek answers. Missions to Mars, for example, are not only searching for water, but also for signs of past or present life. As we explore Mars, we also observe Jupiter and Saturn's moons, like Europa and Enceladus, which have hidden oceans beneath their icy layers. These worlds, though distant, could harbor life in forms we are just beginning to understand. The expansion of the universe also leads us to reflect on time. As the cosmos expands, time itself becomes a factor in the search for life. How much time has a planet had to evolve? Could there be life in a primitive state waiting to be discovered? With every passing second, the universe ages, and with it, the possibilities for new forms of life to emerge. The possibility of extraterrestrial life is not limited to Earth-like planets. Scientists are exploring the idea that life could arise in extreme conditions, perhaps on a gas giant planet where thunderstorms are intense, or on an icy world where life adapts to low temperatures. The expansion of the universe reminds us that life, as we know it, is just one of many possibilities that exist, and this is where the paradoxes of the universe come into play. Could life exist but still be unable to communicate with us? The expansion of the universe creates distance barriers that might prevent us from ever encountering other forms of life. As space expands, the light from distant galaxies may never reach us. This mystery leads us to question whether we are truly alone or if life is out there, but we simply cannot see it. Some theories suggest that life could be a rare phenomenon in the universe. Could it be that habitable planets are a needle in a cosmic haystack? As the universe expands, we must consider the possibility that life exists in a limited number of places. However, even if life is rare, that does not diminish its value. Every discovery we make, every new planet we find, brings us a little closer to answering the question of whether we are alone. The search for life is not only scientific, it is also philosophical. If we find life elsewhere, how would that change our perception of ourselves? What does it mean to be human in a universe filled with other beings? These questions lead us to reflect on our own existence and our place in the cosmos. The expansion of the universe affects not only planets, but also our ideas about life and the connection we share with everything around us. Curiosity about life on other planets is a powerful driving force. It propels us to explore, investigate, and discover. The expansion of the universe invites us to look to the future, to imagine what might lie beyond our small corner of the cosmos. As we continue to advance in our understanding of the universe, each new finding brings us closer to unveiling the secrets that remain hidden. The possibility of life on other planets is a reminder that the universe is vast and full of surprises. As we explore, we realize that we are part of something much larger. The search for answers continues, and every step we take in this exciting adventure brings us a little closer to understanding not only the universe but also ourselves. The expansion of the universe and the possibility of life on other worlds show us that, despite the immensity of space, there will always be a thread that connects us all. The universe, vast and mysterious, is filled with enigmas that leave us perplexed. As we explore its immensity, paradoxes arise that challenge our understanding. One of these paradoxes is the question of why the universe seems to be in constant expansion. What does this mean for our place in it? Expansion may seem like a simple phenomenon, but it raises questions that take us deep into cosmology. Consider a balloon. When we inflate it, the parts of its surface move away from each other. This principle visualizes how galaxies are moving apart in the universe. However, here lies the paradox. Why, despite the expansion, do we not see galaxies colliding? Instead of cosmic chaos, everything seems to follow an order. The answer lies in the very nature of expansion and how space behaves. Time also plays a crucial role in this narrative. What if time is not linear, but rather a fabric that stretches and wrinkles? This leads us to question the concept of time as we know it. If time is expanding along with space, how does this affect our perception of life and the history of the universe? It is a puzzle that invites us to reflect on the very nature of existence. As we delve deeper into these paradoxes, we encounter the idea that the universe could be finite, yet without boundaries. How is it possible for something to have an end but no edge? This notion challenges the logic we have learned and pushes us to reconsider our beliefs about the shape of the cosmos. In this context, the geometry of the universe comes to life, revealing that it could be spherical or even flat. Antimatter, a fundamental component of the universe, also presents its own set of contradictions. Although it is theorized that there should be an equal amount of antimatter and matter, we only find a fraction of the latter in our surroundings. Where is the rest? This question is not only intriguing, but also touches on the fibers of our search for life in other worlds. If there is more hidden antimatter, could there be forms of life that we have yet to discover? Another fascinating paradox is the final fate of the universe. Some theories suggest that everything could end in a big crunch, where the universe collapses in on itself. What implications would this have for existence? The idea that the universe can be born and die raises questions about the cycle of life and time. Are we trapped in an eternal cycle of birth and destruction? Or is there a purpose in this cosmic journey? Dark energy, which drives the acceleration of the universe's expansion, is another source of mystery. What is it really? Although we know it is there, its nature remains elusive. Could it be that this dark energy is the key to understanding the relationship between matter and gravity? The search for answers in this field leads us to broaden our horizons and question the fundamental laws that govern the universe. Speaking of laws, quantum physics also comes into play. This field of study challenges our notions of determinism and causality. What does it mean that, at a subatomic level, particles can be in multiple states at once? The duality of reality invites us to consider that our understanding of the universe may be just a fraction of what truly exists. The paradoxes of the universe lead us to question the meaning of life itself. If the cosmos is so vast and its mysteries so profound, what place do we occupy as tiny beings in a sea of stars? Reflecting on our existence in this context can be both terrifying and liberating. It reminds us that we are part of something much larger, a thread in the cosmic tapestry. The quest for answers to these paradoxes motivates us to continue exploring, investigating, and questioning. Each discovery brings us one step closer to unveiling the secrets of the universe. However, we must also accept that some questions may not have definitive answers. Humility in our pursuit of knowledge is essential, for the universe has the capacity to surprise us in unimaginable ways. As we navigate these complex ideas, it is crucial to maintain curiosity and open-mindedness. Each paradox is an opportunity to learn and grow, not only as individuals but as a society. Science and philosophy can come together to offer us perspectives on our place in the cosmos and on the nature of reality. Finally, it is important to remember that the universe is a vast ocean of possibilities. The paradoxes and mysteries we encounter are just part of the adventure. They invite us to keep exploring, to keep questioning, and to keep marveling at the immensity of the unknown. In this journey, each of us has a role to play, and every question we ask is a step toward a greater understanding of our universe and ourselves. The universe, with its vastness and complexity, invites us to reflect on our existence and the place we occupy within it. As we explore the cosmos, profound questions arise that lead us to question not only what we know, but also what we still do not understand. What does the expansion of the universe really mean for each of us? Are we alone in this immense space? Each of these questions opens a door to a world of philosophical possibilities that invite us to think beyond the tangible. The idea of an expanding universe is fascinating and at the same time disconcerting. It challenges us to consider the nature of time and space. If the universe is expanding, what lies beyond that expansion? Could we say that, in some sense, everything we know is moving away from us? These questions are not only scientific but also confront us with our own mortality and the time we have on this planet. Delving into the nature of time is a profound exercise. Is time a straight line that moves forward without return, or is it rather a cycle that repeats? The expansion of the universe suggests that time, as we perceive it, may be more complicated than we think. Some theories propose that time could be an illusion, a human construct to make sense of our experience. If time is fluid, what does that mean for our decisions and our lives? The search for life on other planets is another of the great questions that arise from the expansion of the universe. If there are billions of stars just in our galaxy, and each of them could have planets in its orbit, is it possible that there are other forms of life out there? The idea that we are not unique in the universe can be both terrifying and comforting. What implications would the discovery of extraterrestrial life have on our understanding of ourselves and our history? Moreover, the expansion of the universe raises questions about the ultimate fate of the cosmos. Will the universe continue to expand forever, or will there come a point when it begins to collapse in on itself? These alternatives, known as the Big Freeze and the Big Crunch, lead us to reflect on the transience of existence. How does it affect us to know that eventually everything we know could disappear? The paradoxes of the universe also confront us with intellectual challenges. For example, the fact that there is more dark matter than visible matter in the universe leads us to question how well we truly understand the cosmos. If there is more than what we see, how much of our understanding is based on assumptions? Each scientific discovery reveals new questions, challenging our fundamental beliefs and forcing us to redefine what we know. The relationship between science and philosophy is fascinating. Science seeks answers through observation and experimentation, while philosophy invites us to explore the meaning behind those discoveries. The expansion of the universe may be a scientific fact, but what it truly means for us, for our humanity, is a topic that deserves deep reflection. Are we simply observing the universe, or are we part of it? We are at a moment in history where technology allows us to explore the cosmos like never before. However, as we venture into the unknown, we also face greater responsibility. What does the knowledge we acquire mean for us? Are we prepared to handle the ethical implications that arise from our quest for answers? Philosophy invites us to consider the impact our actions have on the future of humanity, the existence of black holes. Those mysterious objects that absorb all light around them also raises questions about the fate of matter and energy in the universe. What happens inside a black hole? Is there an end or a new beginning within it? These questions not only intrigue us, but also make us reflect on the cycle of life and death in a cosmic context. The concepts of dark matter and dark energy, which make up most of the universe, lead us to question our own existence. If we cannot see or fully understand these components, what does that mean for our perception of reality? The idea that 95% of the universe is invisible is undoubtedly a reminder that there is always more to discover. Modern cosmology offers us tools and theories that transform our understanding of the universe and our place within it. However, each discovery brings new questions. Are we seeking definitive answers, or are we simply building a broader framework to understand the unknown? Human curiosity is insatiable, and the search for answers can be as important as the answers themselves. The expansion of the universe invites us to look to the future, but it also reminds us of the value of the past. The history of humanity is intertwined with the history of the cosmos. How do our current decisions influence the future of the universe? Every action has an echo in time, and recognizing this can help us live more consciously and meaningfully. Finally, reflecting on our place in the universe confronts us with the deepest question of all. What does it mean to be human in such a vast cosmos? The expansion of the universe may seem like a metaphor for our own lives, where we are in constant change and evolution. Ultimately, the search for meaning in this context unites us all, reminding us that, although we are just a small part of a vast whole, each of us has a role to play in the history of the universe. The universe is a vast stage of mysteries and wonders, a place that awakens our curiosity and invites us to explore the unknown. As we approach the end of our journey through the history of the cosmos, it is inevitable to ask ourselves, what does all this mean for us, human beings, inhabitants of this small and fragile blue planet? The expansion of the universe is not only a physical phenomenon, it is also an invitation to reflect on our place in the grand scheme of things. From the moment the Big Bang gave rise to everything we know, we have been on a path of discovery. With each step, we have learned more about the nature of time, space, and the elements that compose our reality. But what lies behind these revelations? What implications do they have for our daily existence? Science not only seeks answers, but also poses questions that challenge us to think beyond the obvious. Let us be prepared to marvel at the complexity of the universe. The expansion of that vast space around us suggests that everything is in constant motion. Sometimes it may seem that we are trapped in the routine of everyday life, but the universe is in a state of perpetual change. Isn't it fascinating to think that every star in the sky is moving away from us, as if the universe itself is breathing? This idea reminds us of how small we are, but also how extraordinary it is to be part of something so immense. The search for answers about our origin has led us to develop astonishing theories. Cosmic inflation, for example, shows us how the universe expanded at a dizzying rate in its early moments. This phenomenon is not only a key piece in the cosmic puzzle, but also invites us to imagine what might have happened in those initial instants. What mysteries lie hidden in that fraction of a second that marked the beginning of everything? As we explore gravitational waves and cosmic background radiation, we realize that each discovery is a window into the past. Cosmic radiation is like the echo of a great explosion, and by listening to that echo, we can reconstruct the history of the universe. But what does it really mean to hear that ancient music? It connects us all in a cosmic symphony, reminding us that we are part of a greater whole. Questions about dark matter and dark energy, those invisible components that seem to govern the behavior of the universe, lead us to reflect on the limits of our knowledge. What if most of what exists in the universe is something we cannot see or fully understand? This reality challenges us to keep investigating, to keep searching for answers in the darkness. Meanwhile, the formation of galaxies and the creation of the first elements show us how, from small irregularities, the structure we inhabit today developed. It is a reminder that even from the most chaotic, forms of beauty and order can emerge. Isn't it amazing to think that the atoms that make up our bodies were forged in the hearts of ancient stars? Antimatter, with its enigmatic nature, raises questions that we have yet to resolve. What place does it have in our understanding of the universe? The existence of this form of matter leads us to question not only how the cosmos works, but also what it means to be human in a universe that may be full of surprises. The relationship between the Big Bang and black holes is another thread in our cosmic story. These mysterious, challenging objects remind us that even within chaos there are forces that can shape the fate of the universe. Are black holes an end or a new beginning? Perhaps the answer lies in the very fabric of space and time. String theory, although complex, is also part of our quest for understanding. This theory attempts to unify all the forces we know, a monumental challenge that invites us to imagine a universe in which everything is interconnected. Could we be one step away from discovering a truth that has eluded scientists for centuries? Gravity? That phenomenon we all experience daily is one of the keys to understanding the expansion of the universe. How is it possible that such a familiar force can have such a monumental impact? Gravity keeps us anchored to the Earth, but it is also responsible for the cosmic dance of galaxies. A journey through time and space leads us to understand that primordial matter, the basic substance of which everything is made, is the legacy of our origins. What secrets does that matter hold that flowed in the early moments of the universe? Understanding its nature is essential to unraveling the history of our existence. On the horizon of modern cosmology, technological advancements continue to expand our frontiers. Each new discovery opens a world of possibilities, and with each telescope and satellite launched into space, we get a little closer to unveiling the secrets of the cosmos. What new revelations await us in the future? The search for life on other planets is also intertwined with our understanding of the expansion of the universe. If the cosmos is in motion, how does that affect the possibility of other forms of life existing? The connection between expansion and life invites us to dream and question, to explore distant worlds in search of answers. Finally, as we reflect on the paradoxes of the universe, we face questions that still have no answers. These inquiries keep us humble and remind us that despite our advances, there is much we still do not understand. The quest for knowledge is endless, and each step we take leads us to new perspectives and discoveries. As we conclude this journey, it is essential to remember that the universe is a mirror of our own curiosity. Every question we ask, every discovery we make, is a step toward a deeper understanding of ourselves and our place in the cosmos. Exploration has no end, and each of us has a role in this endless story. The adventure continues, and the universe keeps inviting us to discover its hidden secrets.